Hello everyone, welcome to this session. In this session, I'm going to discuss about the properties of steam. As we know that steam is the vapor of the water, and here the steam we are going to use as a medium for conversion of the heat energy into the mechanical energy by using the steam turbines, and later we can convert that into electricity. And for the power generation application, the steam is very important. And the steam is not only used for the power generation, it can be used for the other different applications also. And the steam is of the different types. Okay, that is the different types of the steam or different forms of the steam I have discussed in the previous session. And in those different forms of the steams, it will have the some properties. Then only we can have the distinguish of the different types of the steam. In this session, I am going to discuss of the some of the important properties of the steam. Continuing with that one, here I'll take that is the first one, that is sensible heat, that is denoted by the HF. The sensible heat, it is the amount of heat required to raise the temperature of 1 kg of water from 0 degrees Celsius to the saturation temperature at a given constant pressure. Here, amount of heat whatever we are going to add to the water to increase its temperature from 0 degrees Celsius to the saturation temperature or a boiling point temperature. And that is called as a sensible heat. And the sensible heat is also called as the heat of liquid or a enthalpy of liquid. In this one, it will be in the liquid state only. That's why it is called as a enthalpy of liquid also, or a heat content in the liquid also. Next one is the latent heat of evaporation, that is denoted by the HFG. It is the amount of heat required to convert 1 kg of water at saturation temperature to 1 kg of dry steam at the same saturation temperature at a given constant pressure. Here in this one, first whatever the sensible heat is there, the water is reached up to the saturation temperature. There is a boiling point temperature. Later, if you add the heat to it, the water will start converting into its vapor. And the to convert 1 kg of water completely at that saturation temperature into a vapor, its vapor or a steam, that amount of heat what is required, that is called as a latent heat of evaporation. Okay, in the sensible heat, only temperature increases, the phase will not change and they will be in the liquid form only. In the latent heat, the temperature will not increase. It will remains as the saturation temperature only, but the phase will be changes from the liquid water to the its steam. That is called as a latent heat of vaporization. Moving towards next, that is a superheat. That is called as a H. Okay, here up to the saturation temperature, if you convert all the water into a steam, then it will reach a state of dry steam. And beyond that, if you heat that one, okay, that whatever the amount of heat we are going to add, that is a superheat. It is the amount of heat required to increase the temperature of a dry saturated steam from its saturation temperature to a any desired superheat temperature. Any desired superheat temperature. What temperature we require later onwards in order to have the particular quantity of energy in it. That is a superheat temperature we'll call at the given constant pressure. Okay, there the pressure will be maintained constant in all the three stages. And here the difference between the superheated temperature and the saturation temperature is called as a degree of superheat. How much degree it is superheated, that steam is superheated. Okay, that is measured by using the difference between the superheat temperature and the saturation temperature. This is about the superheat. Next, moving to that one, another property that is called as the dryness fraction of a or a quality of steam. The quality of a wet steam is specified by a parameter called a dryness fraction, which indicates the amount of dry steam present in the quant- given quantity of wet steam and is denoted by the X. Here, if we have the wet steam, it contains a dry steam, some quantity, and also it contains some water particles in it. And here the how much only the dry steam present, that is its quality, that one. It is dry, that much only it is a steam is dry. And that is the how much dry steam is there in the particular quantity of the wet steam, what we measure, that is called as a dryness fraction or a quality of steam. And that dryness fraction is defined as, the dryness fraction of a steam is defined as the ratio of mass of the actual dry steam present in known quantity of wet steam to the total mass of wet steam. Okay, here it is a ratio of, that is a dry steam mass to the total mass of a wet steam. And here for to take that one, okay, the masses we are going to take. Let mg is the mass of the dry steam present in a wet steam. It is a quantity of dry steam only which will be present in the wet steam. mf is the mass of the suspended water molecules in the wet steam. The water particles what are present or molecules what are present in the wet steam. Okay, that mass, its mass we are going to take mf. Then dryness fraction x can be defined as mass of dry steam present in wet steam to the total mass of wet steam. Okay, mass of dry steam already we have taken as mg, and total mass will be mass of dry steam plus of mass of suspended water particles, that is mf plus of mg. That will give the dryness fraction, which will give the quality of the steam. Okay, better quality steam is required. The minimum dryness fraction should be there for the its application and its efficient use of the steam. Next, moving to that one, that is the enthalpy of dry saturated steam. The enthalpy, the total heat content, it is also called. Okay, the steam, whatever form that one, okay, how much heat it will contains, that will call as a enthalpy. And that is for the dry steam and wet steam and superheated steam, enthalpies we need to define. So firstly, we will take that is the enthalpy of dry saturated steam. The enthalpy of dry saturated steam is defined as the total amount of heat supplied at a given constant pressure to convert 1 kg of water into a 1 kg of dry saturated steam at its saturation temperature. It is denoted by Hg and will be equal to sum of sensible heat Hf and the latent heat of evaporation Hfg. Okay, that we can write as a Hg is equal to Hf plus of Hfg kilojoule per kg. Okay, here dry saturated steam means all the liquid water is converted into a steam. Okay, all the liquid is converted into a steam. To convert that one from the 0 degree Celsius, okay, what amount of heat we are going to add it into the to that steam, that will take as a sensible heat, plus later to convert all the water into its vapor, latent heat of evaporation we are going to add hfg, and the summation of these two will give the enthalpy of dry saturated steam. Similarly, enthalpy of wet steam, enthalpy of wet steam means here it is partially water is converted into a steam and partially liquid particles are present in that steam, that we'll call as a wet steam already we know. Here up to the, that is the saturation temperature we are going to heat, that is the sensible heat we are going to take. Then later the whatever the latent heat completely we cannot take because it is not completely water is converted into steam. Therefore, the dryness fraction comes into this play in this one, enthalpy of wet steam calculation. And that can be given as, that is, since wet steam contains water molecules entrained in it, it will have absorbed only fraction of the latent heat of evaporation proportional to the mass of dry steam contained in the wet steam. Okay, that is the mass of dry steam not present in that one. That much of the heat only added to it. Therefore, enthalpy of wet steam is defined as the total amount of heat supplied at a constant pressure to convert 1 kg of water from 0 degree Celsius to 1 kg of wet steam of specified dryness fraction. Okay, from the 0 degree Celsius to up to that wet steam, whatever the temperature is there for a given dryness fraction, it is taken. It is denoted by H and will be equal to sum of sensible heat and the product of dryness fraction and latent heat of evaporation. And that can be given as here, as we know that one sensible heat up to the saturation temperature it is heated, that is added, plus of if all the water is converted into steam directly, we are going to add this HFG, how we have taken like this in this one dry saturated steam, but the partial heat is converted. The some part will be present in the wet fraction of wet form only. Therefore, how much fraction it is dry steam is formed, that is multiplied with the latent heat. Then we are going to get the summation will give the enthalpy of a wet steam. Moving further, enthalpy of superheated steam. The enthalpy of superheated steam means how much amount, total amount it will be present. Okay, that we are going to take from the 0 degree Celsius to the saturation temperature. We are going to heat the sensible heat plus of okay, all the liquid water is converted into vapor. Latent heat of vaporization that should be taken, added, and later beyond the saturation temperature, dry saturation temperature, what amount of heat is added? Okay, that is a superheat, whatever we'll call, and that superheat is also added to this to get the enthalpy of a superheated steam. That is, here it is given the superheat to superheat the steam. The heat is supplied at a constant pressure to the dry saturated steam to increase its temperature beyond its saturation temperature. Therefore, the enthalpy of a superheated steam is defined as the total amount of heat supplied at a given constant pressure to convert 1 kg of water at 0 degree Celsius to 1 kg of superheated steam at the stated superheated temperature, and it is denoted as H and will be equal to sum of the enthalpy of dry saturated steam and the amount of superheat. If the T soup is the superheated temperature, then the Tsat is the saturation temperature and CPS is the specific heat of superheated steam, then the superheat will be equal to CPS minus of multiplied with the T soup minus of the Tsat. Okay, this is the superheat behind the saturation temperature. This much amount of heat is added to in order to heat. It's a superheated temperature. That can be given as H soup is equal to Hg plus of C soup. Okay, that is C superheated CPS that one, and T soup multiplied T soup minus of Tsat. That is the saturation temperature. Okay, this is a CPS. This one, that is the specific heat of a superheated temperature. Uh, that is steam at a constant pressure. And further moving to this one, these are the enthalpy of a different types of the steam. That is next part is the specific volume. The specific volume is defined as the volume of occupied by the unit mass of a substance or volume per unit mass of a substance expressed in meter cube per kg. This is a specific volume generally for any substance we can take. Then concern to the specific volume of dry steam. The specific volume of dry steam is the volume occupied by the unit mass of a dry steam given by Vg. The specific volume of the dry steam is given by the Vg meter cube per kg. Specific volume of wet steam, that is equal to the specific volume of wet steam is the volume occupied by unit mass of wet steam. That is given by Vw is equal to Vf plus of x into Vfg meter cube per kg. Specific volume of superheated steam is the specific volume of superheated steam is the volume occupied by the unit mass of superheated steam. Specific volume of superheated steam is given by the relation V sup by T sup is equal to Vg by T saturation. Therefore, V sup what we required, that we can get T sup by T sat, okay, into Vg. That gives in terms of meter cube per kg. The specific volume we are going to take for all the different types of the steam. Thanks for watching. If you like, share, subscribe and comment.